Hey everyone, welcome to our fourth class of Java Level 1. After today, we'll be exactly halfway through, Java Level 2, sorry. We'll be exactly halfway through by the end of this class. So I'm going to kick things off just like normal. We're going to do a little bit of review, go over the homework, and then move on to our new topic for today, which will be about getting user input, which I've noticed in the homework some of you have already been using. So it might be a little bit of review, but there'll be some new things for everyone. Um, I'm just gonna get started with my screen share, and we can take a look at some review questions, which will lead us to the homework as well. So let me just slides. So last week we talked about methods in Java, how to create them, what they look like, and just playing around with that a little bit. So we looked at kind of what a method looks like, and we labeled the different parts of kind of this first line that we write. Um, I'll give the names, but I will ask a question about this. Um, okay. Oh, okay. No problem, Aaron. I know last week was um, spring break for most of you, so hopefully we have recordings posted on Classroom if you can watch that. But hopefully with a review, it'll be a little bit clearer. But also the new material for today will not be depending on last week's, so um, it should be fine. Yeah. Though I do definitely recommend watching at some point. These methods are very useful in Java, and you're going to be using them all over the place. Um, yeah, but as a review, um, the methods look like this, and this first part was the one I said we're just gonna kind of skip over a little bit for now. This is called the modifiers, and typically the methods that we're gonna write all have something that looks like public static. We'll get more into this later, and we'll see other versions that don't have public and static as well. But after the modifiers, we have something called the return type. In this case, in this example, it's an integer return type. After the return type, we have the name of our method, and this can be whatever we want pretty much. Anything that's a valid variable name is also a valid method name. Um, and then after the name, we have what's called the parameter list. So that's a set of parentheses, and then all the parameters to your method separated by commas. And each parameter is a type and a variable name. So here it takes in two parameters, int A and int B. The parameter list can have multiple parameters. It could have no parameters as well, but you always need the parentheses. So one really quick question about this. Here we have a method that returns an integer type, but we also learned about some methods that don't return anything. So in that case, what do we put as this return type? Does anyone remember? Okay. Thank you, Evan. Thank you, Sophia. Thank you, Jerry. Yep. You're all right. It's void. So it's just kind of a special keyword in Java that you might not have seen before, but yeah, void just means no return type. This method does not return anything. And void methods typically will maybe they'll print something out, so that's why they don't return anything. They might do other things, but yeah, a void is for a method that doesn't return anything. And then we also talked about method overloading towards the end. And I know I went over that very quickly, so I'm gonna answer that question by looking at the homework instead, because that featured method overloading. Um, so this was the homework from last week, which was writing just a couple of methods to practice. And they were all about like converting temperatures from Fahrenheit to Celsius, things like that. So uh, I won't go over everything, but for maybe one thing, um, let's just practice the writing the method again. So if I want a method that converts, say, Fahrenheit to Celsius, doesn't really matter the order right now. Can someone give me what the method, like that first line should look like with all the modifiers, the return type, the name, and the parameter list? What should that kind of look like for a method that takes in a temperature and converts it and gives it back to me? Might take a little bit to type, but I'll be. So basically, your modifiers, return type, your name, your parameter list, then you have your body. So I'm just asking for basically this first line. What should it look like for a converting method? All right, so Evan says public static void F2C into F. Jerry says public static double to cell, double X. Yep. So um, both technically work, but I think based on what I mentioned in the instructions, I think, Jerry, what you have is a little bit better. Specifically, it has a return type of double instead of void. And that's because I wanted my methods to return something rather than like print out the value. Um, and also, I like to work with doubles for these temperatures because I think having that precision with decimals is a little bit better. Um, but this is sort of a design choice. If I didn't give you specific instructions, both of these lines would have worked. But I'm going to go with the second. So we have our modifiers, which are public and static, just like everything that we see so far. Our return type is a double. The name, we can call whatever. To avoid typing as much, I'm going to use a shorter name. But the name could have been whatever you wanted. And then we're just taking in one parameter. Yep. So if we hover over this right now, it gives you an error, and that's because we said it returns a double, but we haven't returned anything yet, right? And so for the body, we can say, I'll make it into two lines. So to calculate what the temperature should be, we're just using the conversion formula, which hopefully was not the hard part of this assignment, which I believe is like this for Fahrenheit to Celsius. And then we want to return C. And once we have this return statement, the red underline goes away. It's happy because now we do return a double like we said it would. And then to use this method, we would have, we could call it in the main method because the main method is special. It's what's automatically run when our program, like when we hit the play button, right? So we can try testing it out. So like this, I'll do this in two lines again. So double result, I'll call it, is just calling our method F2C. And then I'm going to pass it in something easy like 212, which I know should be, it should be 100 degrees Celsius. If so, dot print line, oops, result. And hopefully, if I run this file, hopefully we do indeed get 100. So that was the first part of the homework, which I think most people looked good. The second part of the homework was writing an overloaded version of kind of this one. So we have this method that converts a temperature from Fahrenheit to Celsius. But I wanted to overload this method and create a new one that takes in two parameters that will convert both of them to Celsius and then give me the sum of the two values. It kind of doesn't mean anything, but it just made up something so we could have method overloading. This is where I saw a little bit of confusion, and I think that's just because I went over method overloading very fast at the end of class. But an important thing to remember is that method overloading specifically means that your two methods have to have the same name, but different parameter lists. So sometimes I saw people creating like a second method that would look something like, we're going to ignore the body for now. it might be like f like um I don't know, like some other method, and then it would take in like two um parameters like this, right? And so if you do the body to convert the temperatures and return the sum, everything works how I wanted it to in the instructions, but this is technically not method overloading. Method overloading is specifically when the names have to be the same, right? So now if I call this second method also f to c, now this is method overloading, right? It's just like kind of a nitpick, but if the methods are called different things, it's technically not method overloading. I think there was also a little bit of confusion was like, why can we do this? Um, it seems a little bit weird that we have two methods with the same name. And that's just because we talked about something last week called the method signature. And the method signature is what has to be unique. But the method signature consists of more than just the name. The method signature is the name plus the parameter list. So the method signature for this one is f to c double f. And the method signature for the second one is f to c double f1, double f2. And so notice the signatures are different. So we're fine. We can do this. We can have the same name as long as we have a different parameter list. One thing that's important though is if you have the same name, same parameter list, but different return type, um, this is not okay because the return type is not part of the signature. And so these two methods would have the same signature, which is not allowed. The signature must be unique, right? So just changing the return type is not enough. You have to have a different parameter list, right? Right, because here the underline goes away. If I had this, but different return types, then if I hover over it, it'll say duplicate method, right? It can't tell the difference between the two methods that we wrote. So here's, again, method overloading. You have to make sure that the names match up. Um, one thing I want to mention, oops, let's see. My Zoom is a little bit weird, I think. Sorry about this. Uh, but for the actual method, another thing that you could do is instead of writing the same code here twice, you could just call what you have already used. So you could do f to c on f1, and then you can do f to c on f2, and then return this result. So this is like a one-line version. You didn't have to do it in one line, but this works. And so now I can do f to c with one value, but I can also do f to c with two values. Or maybe let's do 32. Oh, cancel. I have to change this to a different variable name. Looks my camera is a little bit off. Might look a little bit confusing that we see two 100s, but that's just because 32 converted to Celsius is zero. So adding zero doesn't change the result. Yeah, but if we do something like 35, then you'll see the answer is indeed slightly different. All right. So at this moment, I want to take a moment to pause. I want to see if people have any questions about the homework or about methods in general. Um, how to write them, what method overloading is, if that's clear now. Return types. I don't see anything in chat. Again, just one last comment about this before moving on then. Methods are really, really useful, and it's because it allows us to package up our code like this, right? So we package this code into a method, and then we can reuse it in other places without having to rewrite everything. You can imagine that instead of just one line here, I could have a method that does a much more complicated thing. And that way, repeating it would be a lot more costly. It'd be like a lot of copying and pasting. And that's just not very good from a design standpoint. You want to write code once and then reuse it whenever you need to. All right, I see in chat a question. Describe what method overloading is. No problem. So maybe I can even pull up the slides from last class. Um, sorry, see this. So method overloading is when you have two methods that have the same name but different parameter list. Right? So that's the definition, right? And let's look at some examples from the slide again. Yeah, okay. So here are some overloaded methods, right? Um, here you have three different versions of something called my method, right? So the name is all the same, but you'll see the first one takes in an int, the second one takes in a float, and the third one takes in two doubles, right? The body of them is not shown. They could do whatever you wanted it to. And in this case, they all return different types as well. You can have that. You don't have to have that. It's kind of a design thing. But maybe like a question of why do we care about method overloading? One big reason is that it makes our lives very convenient, for example, right? So notice in Java, we have very strongly typed systems, right? So when defining a method, we have to have specific types for our inputs, right? But you can imagine that you would want like a max function or method that say returns the larger of two values. But you can easily define this max function for a lot of different types, right? You can take the max of two ints. You can take the max of two doubles. You could even take the max of an int and a double if you'd like, or maybe a float and a double, a long and an int, right? You can have a bunch of different combinations. One way max functions for our different types, but conveniently they'll all have the same name. And so that way, a programmer who's going to use the methods that you wrote, maybe it's yourself, maybe it's someone else, all they have to know is that there's a method called max, and they can just pass in whatever they want to it, and it will take in, it'll give them the larger of the two values. Um, you don't need to have like max one, max two, max three, max four, and then you don't have to remember like, oh, max four is two doubles, and max two is an int and a long, right? You don't have to like remember that they all have the same name. They all have the same interface, right? So that's why method overloading is useful, or at least one of the reasons. And again, here's like another example with concrete method bodies. So here it's a get some method. Notice the name is the same in both, but here we're operating on ints. Here we're operating on doubles. Yeah. Are there any other questions related to methods? Cool. If anything does come up later, feel free to put it into chat. I'm happy to take a pause and go over any questions that anyone might have. But if there are no questions right now, I'll move on to the new content for today, which is talking about user input. And we're also going to go into exceptions in Java. So let me switch over to these slides. Um, yeah, so user input. Some of you have already played around with this, I've seen in the homeworks. But basically, we want to write programs now that will stop, ask the user to enter some sort of value, read it in, and then do something with it, right? And this allows our program to kind of be interactive, right? It doesn't just always do the same thing when it's run. Um, it will do something depending on the user. And a lot of programs are this interactive sort. So user input is very important. There's a couple of ways of handling this in Java. Um, the slide lists three: scanner, buffered reader, and console. We're just going to focus on scanner for the most part. I think it's the easiest, and it does everything that we need it to do. And the others are pretty similar. So like once you know how to like the concepts involved with working with a scanner, the others should not be too difficult to learn by yourself. So we're going to go into scanner with a lot more depth today. All right. So here on the slide, there's a link, and maybe we can view it really quick. This is a bit of a tangent. If you haven't seen this sort of page before, this is called JavaDoc, and it's very useful, but also can be very overwhelming. But this is like a documentation about anything built into Java. So scanner is a built-in thing that someone else already wrote. Here's describing what it does. So for example, it says here, a simple text scanner which can parse primitive types strings using regular expressions. Some of this might make sense to you, some might not, but we're going to go into it a little bit more. They have example how to use it, which we'll talk about later. And notice there's a thing called method summary. So we just learned about methods last class. Scanners have a lot of methods built into them. And so, for example, things like has next, next Boolean, next string, next int. These are all things that we'll see. But there's a ton of them. So that's why it can be a little bit overwhelming. Generally, you just look at this to like see what's out there, but you don't have to like read the whole page or anything. But it gives you a nice documentation of Java objects. You can usually find this online if you just search like scanner JavaDoc. You'll see it's usually the top search result if you want to find it that way. So, but I'll also put this into chat. That if you want to take a look while we're going through the slides today, you don't have to though. I just wanted to make sure people knew it's out there. So I guess this is jumping ahead a little bit, but here's some of the methods that we saw on that JavaDoc page. Here are they're all kind of similar to each other, and we're gonna see how to use this. But this is how the scanner really works. You're gonna create the scanner, and then you're gonna call basically these methods to get the user input. And they're all very similar to each other. The most basic one is next line, which basically just says, hey, take in a line of text from the user, grab it, and store it into a string. Right? The others are all just variations of that. So for example, next double will say, hey, grab the next thing that the user types, and then convert it to a double, and then store it into a double variable, and then you can return that value. It just does a conversion step in addition to getting the input as well. So if you know that the user is going to enter a number, you can use next double or next int, depending on what you want out of it. If you know, yeah, and if you can use any of the other data types as well. So if we look at a more like full example of this, there's really just two steps. First, we create the scanner, which we do at the beginning. And that looks like something like this. We have a scanner variable. So that's the type here. we have the variable name, which can be whatever we want. And then we say equals new scanner, because we're creating a new scanner. And then inside the parentheses, we say system.in. And what the system.in means is just basically where the user is typing, where you're getting the input from. And system.in is just the console input. It's basically the same place that system.out goes, right? So we've seen system.out.println, that prints to the console in Eclipse. This part right here at the bottom, where I'm highlighting. When we use system.in for the scanner, this is also where we're going to take in input as well. So we create the scanner, and then we basically just call a bunch of next line, next ints, whatever we want, depending on what we're trying to read in from the user. So we can play around with this a little bit. So I was playing around with this a little bit earlier, but we'll start from the beginning. So I have an empty kind of Java class. And if you want to follow along, you can as well. I'm going to start basically transferring over some of the code from the slides. So again, we have a scanner variable. So I say scanner, and then I'll call it S for short. And then what is this equal to? This is equal to a new scanner. But we also have to tell it where we're getting the input from. So we have parentheses and then system.in and semicolon. So I'll take this, I'll copy it, paste it in the chat. If you want to just paste it in onto your own device. But one thing I want to note right now, and this is intentional, you might have noticed that I have some red underlines in my code. Something's wrong here. And that's because to use scanner, we have to do one extra step that I haven't mentioned yet. We have to do an import statement. And that's because scanner is built into Java. So it's already there. You don't have to download anything. You don't have to install anything. But it's not available or visible to Java by default. You have to tell Java, hey, I want to use this thing that you have. And so that's what an import means. It tells Java, hey, bring this thing in because I'm going to be using it. And so scanner belongs to something called java.util. If you just hover over the underline in Eclipse, it'll usually say, hey, it doesn't know what scanner is. And there's some quick fixes. For me, it's this first one. It says import scanner java.util. There's a lot of other ones, but this is the one that we want. And it automatically inserts this line at the top of our file. If you didn't see this, you can type it in manually as well. So it's just this line that I pasted into chat. Import java.util.scanner. And once we have this, you'll notice the red underlines go away. It now knows what scanners are. Right. And so to use the scanner, we saw the next whatever methods from before. So let's just do s dot next line. And so this gets a line of input from the user and gives it back to us as a string variable. So we want to store this into a string variable. So something like this, string input equals s dot next line. And then let's just print it back out to the user. So this is system.out.println input. Right. So this is a very basic program. It's supposed to just read in what the user types, and it prints it back out to us. So if we run this program, you'll notice it might be a little bit confusing at first, but what's happening is we've created the scanner and we're now waiting at this point, right? So the special thing about user input is that it will wait until the user inputs something, right? So right now our program is just paused. It's waiting for us. And so now, if we go to the bottom of Eclipse, where we normally see our output, we can type in something, right? So I can say, hi, class, right? Notice the thing I typed is in green, which um, the stuff that the program outputs is usually in black. And um, to show that I'm done with the input, that I'm done typing, I've hit enter. And immediately you can see it prints it back out to me, right? So this green is what I typed. The black is the output of the program, where it just prints out what I typed in. So are there any questions right now about Scanner, how to use it, um, anything like that? If you were following along, if anyone has problems getting to this point where you can have like a simple program that just prints out what you typed, I'm happy to debug with you. I do not see anything. Um, some things maybe to make this program a little bit better. You'll notice that when we run our code, it's a little bit confusing because nothing happens at first. A lot of times when you're taking an input, you might want to give a prompt first. You might want to tell the user, hey, I want you to type something. And you can do that by doing a print statement before our scanner tries to read something. So we can do system dot out dot print, and then it's like uh, enter, uh, please type. Right? And then I have the same code from before. And now when I run it, oh, you'll notice I have some output. It's like, please type. Okay, I type some stuff, right? Hit enter, and then it prints it back out to me. Notice this is something I mentioned from before, or not mentioned before, but notice here I just did print instead of print line because I wanted the input to be on the same line. I didn't want a new line. But uh, you could also do print line instead, and it would just have your prompt, and then you type on the line after it, and then so Jerry, you said, is there a way to make it copy instead of writing it to the console? Um, I'm a little bit confused, maybe. What do you mean by copy? So I know we're printing it out right now. We're like repeating what the user typed in, but um, I'm a little bit confused, but why what you want it to do instead. Are you sure? I'm happy to uh, answer any questions. Okay. Um, all right. Um, so the other thing I want to show off with scanners right now is just one of the other next methods. So here we use next line. Let's practice using like next int. Okay. So if I just kind of repeat what I have before. So again, here I'm creating my scanner. I'm prompting. I'm I'm reading the input and then I'm printing it back out. Here, maybe I'll do something a little bit different. So here I'll say, um, I'll do like a simple calculator, right? So like enter a number, right? And then instead of next line, I'm gonna do next int, right? And then since I did next int, I want to change my variable, right? Instead of a string, it needs to be an int variable because I said read in an int, right? So I need to store it into an int. And then I also have to change the name of it, so I'll call it like first num. And then I'll get a second number. Right, so I'll just repeat this process. I'll prompt, I'll say enter a second number, and then I call it second num. And then I'll do um, the sum of them. So first num plus second. So if I run my program now, I see it prompts, and then this is it just echoes it back out to me. But now here's the new part where it says enter a number. So maybe I do 7, and then a second number, maybe I do 5, and then it prints out 12, right? So here's an example of using next int instead of next line. And again, oh, sorry. The difference is just that now it does an extra step where it takes our input and then converts it to an integer. And then we now have an integer to work with instead of a string. Aaron, I'm very glad actually that you asked that question. What if you don't type a number? This is something I was going to talk about towards the end of class, but maybe I can just show it off now and we'll discuss a little bit more in detail later on. Um, but if we type in something that's not a number, like, I don't know, like the letter A, you'll notice we get red text. We get a problem. And we're going to talk about this a little bit more. And especially in next class, we're going to figure out how to deal with this ourselves. Um, like how to handle this, how to make it not trash, right? Yes, we're going to deal with exceptions. Um, um, so this is about it for user input. Again, the pattern is just always create a scanner, maybe do some prompts, read in some input using next line, next int, next double, next whatever you're trying to read in. And then you have it as a variable in your code and you can do whatever you want with it afterwards. So are there any questions about user input so far? Um, Before we go into exceptions too much, um, there's one more thing I want to talk about with scanners, and that's um, reading file input. So this is very closely related to user input, but a lot of times you'll want to create a program that reads in data that's from a file on your computer, right? Maybe you have a text document that has a bunch of words and you want to process it with code, right? So how would you do that? And it turns out Scanner is able to read in files as well. It doesn't just take an input from the console, but it also can open up files and read the contents of those as well. So we go back to the slides here. So the scenario is that you have a text file called test.txt, and I want to use Scanner to read in the file. So I'm gonna do this in a slightly different way from the slides because the slides shows something that we haven't seen yet. And I'm gonna delete this for now. And first, I'm trying to read in from a file, so I need to make a file. So in Eclipse, you can do this by just doing new text, untitled text file. So I can say, hi, this is a file. And then maybe I'll do smiley face and we're done. So I can save this. I think I need to save in the right place. So I think here, make sure this works. And you can see inside of my project explorer, package explorer. It's a little bit small, but you can see I have a test.txt file. And this is important. It should be in the same place where your Java files are as well, just to make your life a little bit easier, so you can access it easier. But to read in the text from this file, we need to do one extra step that we didn't do before. So before we created our scanner by doing like new scanner system.in. But if you remember, the system.in, what this is meaning is, where is our input coming from? Well, we don't want our input coming from the console anymore, so we need to change what this is. We want this to be the file, right? The text file. And so we can do that in Java. So I'm going to create a file variable, and then it's going to be a new file, and I give it the file name. So here it's test.txt. Right? And just like before, we have some underlines that we need to fix. So if we hover over it, one of the first issues that we saw before is that it doesn't know what a file is. And this is resolved by an import from before. So in Eclipse, the first default one is the one we want, import file from java.io. So here we have another import statement. So we create this file object, and now we just pass this file object into our scanner. We just say F, right? So we take our file object, we put it into the scanner instead of system.in. Because instead of reading from the console, we want to read from the file, right? But here is where we get to our second problem that we have to resolve. And here's kind of a segue to the second topic that we're going to talk about, exceptions. So it says unhandled exception type file not found exception. For now, all you have to know about exceptions are that exceptions are like errors. This red text that we see that crashes our program, that's a result of an exception. And the terminology that Java uses is that things will throw exceptions. So if something can go wrong, it will throw an exception in the case that something did go wrong. So methods can throw exceptions. Here, when we're creating the scanner, this can throw an exception, specifically a file not found exception. If this file test.txt doesn't exist, there's going to be a problem, right? And for now, we're not going to do anything fancy with this. What we're going to do is the first fix available adds throws declaration. And if you notice, what it does is it adds some text at the top of the main method. It says just throws file not found exception. What this means is that inside this method, if anything causes a file not found exception to happen, specifically when I create the scanner, what's going to happen is the main method is just going to be like, well, okay, I don't know how to deal with this. I'm going to give it up to whoever's higher up than me, right? The problem is that main is the highest up that you can get. There is no one higher than main. And so when you throw an exception from main, your program just crashes. You're going to see something like this red text like before. So here's an example of main throwing an exception. We just didn't see it explicitly. But Java is a little bit safe in this case. It says, hey, I know that this thing can cause an exception, can cause an error. So you need some way of handling it. The way that we're handling it right now is just a really dumb way. It just says, hey, I don't really want to deal with it. Someone else will deal with it, right? I'm just going to pass it on, right? And hope someone else knows how to resolve this. Yeah. But once we get to this step, we can use the scanner just like before. So we can do something like string s equals s dot next line, and then system.out.print s. Oops. Oh, my bad. My variables are a little bit messed up, but here. So we call next line our scanner, we store it into a string variable, and then we print it out. So if we run this, oh, okay, I think actually this actually is the exception. So I think something's wrong with my file structure. Okay, so I think maybe it should be in this location. Let me double check. All right. All right, yeah. So I did this a little bit incorrectly. This is a result of where your text file is placed. So actually you want it outside of your source folder. So in your package explorer, you want to make sure that if you close the source folder, you can still see test.txt if you're doing this in Eclipse. You don't want it within the source folder because the default place it looks for your files is right here outside the source. But again, you noticed if it can't find it, this is the file not found exception. It doesn't know where the file is. But if I place it where it does belong, you can see it prints out hi. And that's because hi is the first line of my file. If I do this a couple more times, you'll notice I can print out more of my file, right? So hi, this is, right, is the first 3 lines of my file now. But maybe I want to print out the whole file, right? I want to print out the whole file, but I don't know how many lines my file contains, right? Does anyone have an idea of what I might use? A tool that we've learned in the first class that can help us with this. We want to do something over and over again. We want to print out lines from a file, but we don't really know when to stop. So yes, we want a loop. And I think, Aaron, you have the right idea. We actually want a for loop. So we want a while loop, sorry. So yes, we want a loop, but specifically we want a while loop. And we want a while loop in this case because it's hard to write a for loop to handle this. We don't know ahead of time how many lines our file has, right? You can imagine this file might be coming from someone else, and we can't open it up easily ourselves manually. And so a while loop is a lot better in this case because a while loop can handle like an unknown number of iterations a lot easier. A while loop just has a condition for our looping. And what should our condition be? It should be something like, as long as there's more stuff to my file, I want to print out a line, right? As long as there's more stuff, get a line, print it out. See if there's more stuff. If there is, get a line, print it out, right? So putting this into code, we would have something like while, and then I'm going to leave the condition blank for now, but we want something like, I'm just going to create my string variable up here. Line equals s dot next line, system dot out dot print line, right? So we want to do this over and over. And this condition should be something like, while there's still stuff in our file, loop, right? And conveniently, Scanner has this functionality built into it. So maybe if we go into Java docs, let's see if we can see it very easily. But Scanner Java docs. So if we take a look at the methods, you'll see kind of these as next whatever, right? So you can look at this, but conveniently there's this has next line. So if I zoom in a little bit, you'll notice, well, I zoomed in a little bit too much, but this is saying the return type, right? At the top is well, yeah, the type means return type. So this has a return type of Boolean, and it says returns true if there's another line in the input of the scanner. So while there's stuff, this will return true. And once it runs out of input to read, it'll give you false. And that's exactly what our condition should be. So while s dot has next line, get that line and print it out. Right. And so now if I run my code, you'll see it prints out everything automatically for me. Right. And all I needed is just a while loop. If I add more lines to my file or text here, right? And then I save and run, you can see it can handle that for me because the scanner just loops as long as there's more text to read, right? Doesn't matter if my file has 1 line, has 2 lines, has 100 lines, it will handle it automatically. And so this is kind of a cool thing with scanners and also the while loops that we learned from before. Yeah. So now I want to take a moment to pause again because we covered scanners for user input, and now we also covered how to do scanners for files as well. So I want to see if anyone has any questions about what I just did. Files has a little bit of extra stuff involved where you have to like create this file first and give it to scanner. And then this sort of structure that you're going to see a lot with files where you want to go through the whole file. And how do you do that? You just have a while loop with this condition here. But yeah, if there's anything confusing to anyone, I'm happy to go over it a little bit again. Don't be shy. How do you make the text.txt again? All right, no problem. So there's to make the file, you can do something like if you have your project, so mine is called AOE Spring 23, but if you have your project and you right click on it, you can do new, and towards the bottom, there's the untitled text file. Okay. That will bring up an editor where you can type whatever you want, right? Type some stuff. And when I save it, it will ask me where to save it. So here I just click the project that I wanted, and then I give it the file name that I want. So test2.txt for me, since I already have a first one. And then I click OK. And it should show up on the left. Unfortunately, I don't know how to make this text bigger. So I know it might be a little bit small on your screen, but notice I have test.txt and test2.txt that shows up here. One thing you want to check is that if you close the source folder, which is where your code should be, it should not be inside of the source folder. It should be outside of it. Right? If it's inside, like here, I moved test.txt inside, and if I close the source folder, you'll notice it disappears from the list. All you have to do is just kind of drag it out. Drag it to, just click and drag it to where the project name is, and it will automatically place it outside the folder. So now if I close it, you can see the files there. And just to show it that it works, I can, instead of text.txt, I can do test2.txt. And you can see this is my other file. It has just a bunch of gibberish. Right. So Henry asks, what does the throws thing do again? So that's a great question, and it's actually what I want to talk about next. So if there's other questions, I'll answer that first. But if not, I will go into this throws thing a little bit more in detail. Um, Right. I don't see anything for now, but towards the end of class, if any other questions arise, I'll happy to answer them. But to go back to your question, Henry, so the throws thing has to deal with exceptions in Java. And we've seen a couple of them today. You might have seen some of them before. So really quickly, let me just like comment out this code. And another thing that you might try to do is like print line. Here's another thing that causes an issue. If you do like 5 divided by 0, right? If you learned in math class, dividing by 0 is not allowed. And if you try to do this in Java, you're going to get another kind of exception. So exceptions are errors in Java, and sometimes Java will force you to deal with how to handle them. There's two ways on how to do this. One that's kind of dumb and one that's a little bit smarter. The smarter way we're going to focus on next week. But kind of the dumb way of handling it is just saying, pass it on to someone else. Have someone else deal with it. I don't want to handle it myself. I'm just going to try to get someone else to do it. And that's what this throws is saying. It's saying, hey, within this method, I know that there might be a file not found exception that will occur. And so I don't want to deal with it myself. I'm just going to say, if anything happens in my method, I'm just going to toss it up to the next person in line. And maybe something that will be a little bit more clear is let's take all this code that I have and I'm going to put it into another method, right? Static, it's going to be a void method. I'll call it read file, right? And I put this code here. And let me get rid of this for now. So you'll notice I have the red underline. And that's because, again, this line of code where I create my new scanner can cause an exception to be thrown, right? If this file doesn't exist, which we've seen before, it might not exist, then there's going to be a problem when we create the scanner. And so, again, we have to resolve this some way. We have to either do something called a try catch, which, again, we're going to talk about next week, or we just do a throws declaration. So if we click this, Eclipse automatically adds this to our method, just says throws file not found exception, which means that this method, read file, it may run into a file not found exception. And if it does, all it does is throw it up the chain. And when I say up the chain is because methods can call other methods. For example, we've seen this in the homework, right? In your main method, you call the F2C method. You also call the print line method, right? And so in our case, if we go into main and try to call read file, right, we're going to get the error again because read file now, we know it can throw this exception if something goes wrong. So now we say, okay, well, if this method throws an exception, how does main handle it, right? Because main is using this method. And so we have to add throws declaration again, right? Because main will call read file. And read file, what it does is does this kind of scary line of code. This line of code might cause a problem. And if it does, it will throw it up. When we throw it up, it throws it to main. And the main says, okay, now I have to deal with it, right? It's like a hot potato, right? We toss it to someone else. Now they have to deal with it. So main has to deal with this file not found exception. And we're just saying, hey, just throw it again, right? Toss it to the next person. The thing is that behind the scenes, main is a little bit special. It's what's automatically run. And when main throws an exception, it causes our program to crash, right? Which is fine for now. Next week, we're going to talk about how to handle exceptions without crashing. But if we run this code, you'll notice it doesn't always throw an exception. And that's because the file not found thing, sometimes it happens, sometimes it doesn't, right? It's it's only when the file doesn't exist that we have the exception. So if everything's fine, our code just runs like normal. But if I try to open a file that doesn't exist, right? Uh, right, then what's happening here is that, and you can actually read it here, right? If we look at this, we'll see class 4, which is the name of my file, read file, which is my name. So there's a problem here, and that went up to main as well. And then from main, there's nowhere else to go, right? And we crash, right? So this line of code, right, says Java colon 14, line 14 right here, caused an error. And that in turn went to line 9, which is right here. And this throws the error again. And then main throws it, so we crash. Hopefully that made a little bit more sense. You're gonna deal with this in the homework as well. We're also gonna go over the exception idea much more in depth for next week. But yeah, so the homework for this week, I'll just go over that really quickly at the end of class. Don't worry, the slide deck is long today because it contains the stuff for next week as well. But the homework really quickly is kind of similar to what we already built today, but basically just adds another step. It's going to be using user input and file input at the same time, where you have a method that you pass it a file name and it will open it and read the contents. And then in your main method, I want you to get user input. So the user is going to type in a file name. Your program should take that file name, pass it to the method that you wrote, and that will open up the file with that name and then print out the contents. Yeah, so this is going to be user input, file input all in one, and also practicing writing methods that we did last week. All right. So that's what I have for class today. Hopefully user input was fun. I think it's pretty cool because now your programs, I think, are a lot more powerful when they can interact with the user. You can do a lot more interesting things. But yeah, if there's any questions, as usual, I'm happy to stick around a little bit longer and go over them with you. If you don't have any questions, hope you have a great week, and I'll see you all for class number 5 next Monday.